Well, thank you for those that have joined us online, and I know that we will have some people that will be watching this recording a little bit later. And a huge welcome to Trevor and Nicholas Moretti. Thank you from Microsoft Azure for joining us today for today's webinar. So I'm Asha Stabak. I'm the Business Development Manager of the Australian Space Data Analysis Facility. And we've been established by the Australian Space Agency, as well as funding from the WA government through GIPSI, which is really here to help accelerate the utilisation of space data. I'd like to acknowledge and pay my respects to the land on which we meet. I'm meeting from the Wadjuk Noongar Nation over here in Perth, Western Australia, where we are currently sweltering, but we've just had the new season being welcomed in. So certainly like to acknowledge and pay my respects to those elders, past, present and emerging. I'm really excited to kickstart this, and this is the second in our series, the first one that we had a couple of months ago, and it's great to be able to showcase how the organisations on a global scale are supporting the access and utilisation of space data. I will hand over to Trevor and Nick for today's session. For those that are joining us online, please feel free to send through questions as they come up, and we'll have time at the end for a bit of a Q&A.
Awesome. Yeah, thanks for having us. I think both Trevor and I are sort of really excited to be here. We thought we'd give you a bit of an overview of some of the space work that Microsoft is doing, and then also how we are applying some of sort of that space data to some really interesting sustainability problems. So hopefully I'll sort of make a weird tie from sort of what I talk about to what Trevor talks about, and it should all make sense. So Azure Space, or sometimes referred to as Azure Space in Australia, is really Microsoft's effort to apply cloud computing to the space industry. This is our mission statement or vision, but there's three things that sort of always stand out to me. The first is a new set of offerings, so actually building new things targeted towards the space industry and to help other industries leverage space data. The second is a partner ecosystem. So Microsoft does so much of its work with partners and owes a huge amount of its success to the success of our partners, and space is no different, and I'll talk about our partners throughout this. And the innovation-centric global strategy. So we're really trying to bring sort of the best of Microsoft, the best of the hyperscale cloud and Azure to the space industry to do a step change in that industry and the capabilities that it involves. Sort of like to start these sorts of talks with what is Azure. Azure is Microsoft's cloud computing offering. There is a huge amount of infrastructure that underpins this, sort of a global infrastructure, data centers, networking, all the services that run on top of that. Azure is used by 95% of Fortune 500 companies and has a huge footprint throughout the world. And sort of this next question always comes up is, why is Microsoft getting into space? At a surface level, it seems like almost quite a strange decision. But space at its fundamental level is all about data and connectivity. And that's what the cloud and Azure is all about too. Microsoft has a strong skill set and strong knowledge base in data and connectivity. It's just with space now, these connectivity links are through satellite communication paths instead of terrestrial fiber. And that data is now generated by satellite platforms or transmitted through satellite platforms than traditional methods. So our efforts for space really fall under four big pillars of effort. The first is global connectivity, which is how do we connect anyone or anything around the world? Azure Orbital is our ground station as a service product, which I'll talk a bit about in a second. Artificial intelligence for space is how do we turn the large amounts of data generated by space assets into knowledge or insights that is useful for other industries. So whether that is mining, agriculture, financial services. Digital engineering is how do we enable the satellite developer or the space developer to build tools, to build satellites better using digital tools. So things like Azure Orbital Emulator, which enables people to emulate how satellite constellations perform. Then also put hardware and software in the loop to do that at sort of massive scale in real time and understand what they're going to build before ever actually needing to build it. And Azure in Space is a really cool one, but it is how do we get all this great infrastructure that we have built on the ground to support things in space. So for example, the International Space Station is a laboratory that's been orbiting space for many years. How do we sort of use Azure to help the space station? Mankind, or sort of humankind, will probably move off Earth beyond the International Space Station at some point in the future, whether that is to the moon or Mars or somewhere else in our solar system. Compute, data, connectivity, it is such a fundamental part of our lives now. So how do we use Azure to support those sorts of operations? So Azure Orbital is our ground station as a service offering. I wanted to talk to it today because it's a connectivity path, and being able to get data from where you need it sort of into a data center to do processing is really crucial. It's about reducing the friction to get access to satellite communications or satellite ground stations. So we are partnered with people like SES and KSAT and Viasat about bringing their infrastructure into Azure. Some similar things for modem providers with Kratos and Emergent. But there's sort of two use cases that we're going after. The first is global communications, which is connecting anyone around the world using broadband satellite communications. So whether that is a mine site in remote Australia, a farm site in remote Australia, connecting that through satellite communications directly into Azure to be able to process data, understand what's happening at that remote site, and use those big, sort of impactful resources. The second is Earth observation, which is targeted at satellite operators or is used by satellite operators. A satellite operator logs into Azure Orbital and can downlink data from their satellite as it flies overhead directly into Azure. I like sort of showing this slide because I think it makes Azure Orbital very real. On the far two left slides, ground stations that Microsoft has built and is operating ourselves as part of Azure Orbital. So one in Washington and another one in Sweden. I then talked about before integrating some of our partners' infrastructure into Azure Orbital. And that's that photo in sort of the middle right. That is one of our partners' sites in Norway, KSAT. And so bringing their infrastructure into Azure Orbital so people can book it through our portal. And then on the far right, sorry, it's a bit of a pixelated photo, but the best I could find is one of our partners, SES, building ground stations or gateways at our data center location in Phoenix. So those 4 pads on the right are where their gateways are going to go. And then our data center is that sort of nondescript building on the left. So being able to downlink data or have a communication link directly into Azure right next to it, I think is really powerful and enables a huge amount. Artificial intelligence for geospatial intelligence or for geospatial data is what I talked about before, about how do we take the huge amounts of data generated by space assets and turn that into information that is useful to people in the traditional industry verticals like mining, agriculture, sort of financial services, insurance, things like that. Microsoft isn't launching our own satellites to collect that data. Similarly, Microsoft doesn't have the breadth of knowledge or really the capacity to be able to develop analytics for every single one of those use cases out there that people are interested in. So for us, it's how do we build a platform that enables data from other sources to come in to be combined with analytics from other sources, and then that to be delivered to different industry verticals or different people at sort of old technical levels to get that insight from data. Down the bottom, there is sort of a few of the different areas that we are pursuing. I'll just touch on a few of them that I think are really interesting. The synthetics work. Microsoft has a long history in gaming and building virtual worlds that are very realistic. So leveraging some of that work to build synthetic data sources that are labeled on a per pixel level. What that enables people to do is start training machine learning algorithms at huge scale. One of the big barriers to machine learning algorithms for geospatial data is just getting access to labeled data. So using synthetics to generate pre-labeled data, we can start reducing that barrier to entry. Azure FarmBeats is also a really interesting product from Microsoft. The human population is going to grow. We are going to need to feed that population. We only have a certain amount of land mass. So how do we enable data-driven farming to better produce food? And that's what Azure FarmBeats is about. There's a huge amount of technology that plays into that product, and I cannot do it justice in the time we have, but a lot of it uses satellite data to either augment sensors on the farm or produce sort of insights at a large scale on the farm. So things like having pH sensors or soil moisture sensors at different points in the farm, and then being able to use satellite imagery, fuse that with that the in situ measurements to be able to interpolate what's happening across the entire farm and build really detailed maps. So I just want to move into talking about a few interesting use cases that we have done with space. Typically, when people think about sort of space data, they instantly go to geospatial data, which is a big and important part, but there are a lot of different aspects of space data and how to think about that. I'll play a video in a second, but as a quick rundown, we worked with HPE, who have a computer on the International Space Station, to demonstrate how you can crunch data at the edge, use a sort of very limited space link to transmit sort of small amounts of information, and then use the power of the hyperscale cloud to do more processing of that information and then send back up things to the astronauts that they may care about. So in this case of data is data that was generated in space about genomics, and in that processing sort of happening at the edge and also in the hyperscale cloud.
Spaceborne Computer 2 is the latest available edge computing resources on the International Space Station. We had to survive the shake, rattle, and roll of launch. We had to properly package it so that it could be stored properly, and we had to come up with the instruction set on how it would be installed by our astronauts. The latency from space on the International Space Station is significant. It takes a very long time to get the data from the International Space Station back to Earth.
The space station has limited bandwidth. We are only allowed to use 2 megabytes per second for only 2 hours per week. So that means if you're running experiments that uses a lot of data, you can't send all your data down to Earth. You need to do some processing using the power of HPE's Spaceborne Computer 2, take a look at your data and distill it down to what's interesting. Then you can send down interesting events down to Earth, where you can then leverage the power of Azure and the public cloud to process at scale. With that, we can also bring tools to bear, such as Microsoft Genomics. And we take that sequencing data and see, is there anything interesting that we need to tell the astronauts about what we have seen?
One of the great things about Spaceborne Computer 2 being developed with an open source software is that here on Earth, it's really cool that for me as a developer, I can use those same tools. It really increases the developer velocity to creating something useful. So I can know with confidence that, say I go to the repository for this project, I can clone it from GitHub, I can open it in a browser with GitHub code spaces, or I can open the solution with Visual Studio Code, build it with Docker, and I have the exact same tools that I know are going to be present in the Spaceborne Computer 2. So I can validate, dev, and test locally, deploy to Azure, and deploy to space confidently. It's cool that we can take patterns that we know exist today, repeat them, stand on the shoulders of the giants that came before us, and build better things.
It's stuff that every developer knows how to work with. Building on open source components of Linux and Docker containers means that there's a much wider group of developers that can develop applications that are meaningful in space.
Open source technologies allow us to create unique and interesting things, and then Spaceborne Computer 2 gives us the horsepower to do them.
By conducting experiments with off-the-shelf technologies on the HPE Spaceborne Computer 2, we can prepare for missions that are further out. So if we're preparing to put humans on the moon or on Mars, we want to know how we can build these patterns of processing at the edge and bursting down to the cloud now while we have the space station before we go to much further and more difficult places. I'm looking forward to seeing how Microsoft brings our experience with democratizing the technology to help bring space out to every industry.
When we build these things today, our hope is that we can build truly game-changing things in the future for both astronauts on board, our partners, and the people here back on Earth.
So I think that's really a really cool project. There are some parts that stand out to me. And the first is that data compression to use a really limited bandwidth link that exists across a huge amount of space applications or sort of applications here on Earth. The other part that I really like is the open source part. So sort of building these open source tools in our development and our experiments that then we release to the community to help them sort of build and iterate and understand these things. So I think that's really cool. CSIRO Space Cows is another cool project. Also has a really cool name. But Space Cows is about tracking feral animals in Arnhem Land to better protect the indigenous environment and culture. I might just play a video and then I'll talk to, again, the components that I like at the end.
High up in the vast quiet of space, a constellation of satellites is gathering data to help protect our planet. In Australia, Microsoft and the CSIRO have collaborated to bring together Indigenous knowledge, space-age innovation and science to help protect the land and important cultural sites from the damage caused by feral buffalo and cattle. Introducing the new Space Cows project, a smart herd management program that tracks feral herds across more than 22,000 square kilometres in the northern region of Australia, from Arnhem Land to the Cape York Peninsula. Using the innovative combination of Indigenous knowledge, low Earth orbit satellites, and Microsoft Azure Artificial Intelligence platform to interpret the data, Indigenous rangers have new tools to help manage their land and create new economic opportunities. What is Space Cows? It means we can see a cow or buffalo from space. We can use cloud and AI to predict its behaviour, to track the herd, to protect the land. Indigenous communities, Microsoft and the CSIRO collaborating with a range of partners, land, space and people working together for a better future for the planet, a shared future.
So the parts that I really like about Space Cows is sort of space data, and data analysis is one component of many that come together. So combining Indigenous knowledge, sort of science from CSIRO, space-enabled data, AI, sort of the hyperscale cloud, and they all come together to achieve this outcome, which I think is really cool. So I just want to touch on a few things that we're doing in Australia in terms of space. We're working with the Australian Institute of Machine Learning about really sort of how can they leverage some of the Azure Space products to enable their research. They are some incredibly intelligent people that want to do or are doing space research. And if we can use that power of the cloud to enable them to sort of understand how satellites work in a digital world, sort of build software that they would like to run on satellites, but running on a digital satellite in the cloud instead, I think there's a lot that can be done there. I'll talk to Microsoft for space startups in a little bit more detail in a sec, but it's how do we support Australian space startups to build that ecosystem, build tech, and really grow and scale into this thriving ecosystem, which I think is really cool. We have a strategic collaboration with the Australian Space Agency to help them achieve their goals. We're working through a number of initiatives with them at the moment. And then we're also working with Nokia about how do we combine 5G networks, 5G connectivity, and also space connectivity in a seamless way to bring connectivity, the power of the cloud applications to different scenarios where they might have had issues with connectivity before. So things like smart mines, smart mining, smart mines, smart agriculture, things like that. And this is the last part I'll touch on before I hand it over to Trevor to talk about some really interesting things. But getting started on Azure is really, really easy. I talked about Microsoft for Space Startups Australia before, but through that program, you can really get access to 3 things. The first is sort of access to tech. So up to $150,000 USD in Azure credits and $350,000 USD in total benefits. Also some free seats to sort of, a lot of Microsoft software as well. Access to mentors to help you build your business. So whether they are sort of tech mentors in all the different aspects of Microsoft, or sort of business mentors, marketing mentors, all those sorts of things. And there's also the potential to go to market with Microsoft. So Microsoft helping you to sort of sell your solution into some different customers, partners, wherever we think there is a joint value proposition. There are a huge amount of free Azure services that we offer. There are some popular services that are free for the first 12 months with some Azure credits. And then there are services that are always free up to a certain point. So I'd encourage you to check those out. If you just type in sort of free Azure services into a search engine, it'll come up. And then Azure certifications as well, sort of understanding how you can best leverage all these things. There are some certifications that Microsoft offer. I would really encourage you to check them out, sort of understand a bit more, sort of start using those free services, experiment. And then if you've got an idea that you want to take further, whether it is sort of early stage or more mature, apply for Microsoft for Space Startups Australia. We'd love to have you on board. We'd love to figure out how we can help you build your business. That's all from me from a space perspective. So I'll stop sharing my screen and let Trevor jump in.
Fantastic, thanks, Nick. And as I said, I'll talk a little bit now about the planetary computer. Let's hope I get the audio switch to work. This doesn't go very well, does it? All right, there we go. So assuming my PowerPoint is up and running, yep, thumbs are up. So let me talk a little bit about the planetary computer, which is kind of deep diving into one of those applications that Microsoft is building out in order to take a whole bunch of the innovation and capability that's coming from space and from Earth observation, and to really try and help channel that into impacts back here on Earth. And to be frank, the reason we're doing it, you don't have to look very far for a lot of people crying out and demonstrating and making the point just how urgent some of the environmental and climate challenges are that the world is facing, right? They are here today. These are not challenges for our children. These are not challenges and impacts that are going to hit us in 10 years, 1 year. They're here upon us today. And ultimately what that means is that we have to move faster. All right, we need to go faster in terms of our ability to understand the environment, in our ability to monitor the environment, but more than anything, our ability to better manage and use those insights to make better decisions about how we actually care for the environment, care for biodiversity, and really dealing with avoiding catastrophic loss of biodiversity is actually one of the 4 sustainability commitments that Microsoft made last year. So we made a series of sustainability commitments: be carbon negative by 2030, we'll be water positive by 2030, a zero waste company. And in biodiversity, we really committed to 2 things. So we committed to protecting more land than we use, and we committed to building out the planetary computer to really help bring all of the power of big data, analytics, and to environmental management and to sustainability challenges. So the first question that really gets asked quite often is, well, what is a planetary computer? So I actually want to go into that a little bit, and then I want to talk through some of the places where that's being used and some of the things that I think are important in the characteristics of this sort of work in order for it to go from cool tech to impactful change. So first off, what is it? So at the heart of the planetary computer are really 3 components, right? There's geospatial data, there's a whole bunch of data querying and processing APIs, and there's a compute environment. And when we say you're working with the planetary computer, in honesty, we mean you're touching any one of those. So let me run through what each of those are. First of all, in terms of geospatial data, we currently have over 23 petabytes of global satellite data. So you can see the list there, nothing too surprising, but those large public good global missions all being brought into one area, all being corralled and made available on Azure. But I'd also note that it also includes a whole bunch of weather and climate data, a whole bunch of land cover data, and increasingly biodiversity data. And it's one of these areas where, as we see new innovations leading to new global data sets, we then feed those back into the planetary computer so that they're available to everybody. And I'll talk about an example of that in a moment. When we're thinking about the APIs, we're talking about effectively based off the spatiotemporal asset catalog. So everything is built around open standards, open APIs, and tools that allow you to do spatiotemporal queries as well as image processing queries, being able to do things like blending images, resampling, all the kind of classic geospatial API access. But the point I made at the start and that I'd emphasize is to go along with the open data that is sitting underneath this. We are very focused on investing in the development of and the use of open standards, open APIs, and really cloud optimized geotips with stacked front ends is the bread and butter in terms of the technology that the planetary computer is built upon. And then we actually have the Compute Hub. So the Compute Hub is built with a Jupyter Lab front end. It gives you access to the data and the APIs, as well as your data on Azure storage, and through things like Dask, being able to do distributed processing, large-scale, massive compute without actually having to know or think through the complexity of distributed processing. And again, one of the key points I'd highlight here about this Compute Hub is that it's all built on both open source technologies. Pangeo is really at the very heart of it, as well as being built with an open architecture. And again, I'll come back to how important that is for us as we get a little bit later into this presentation. So those are the kind of core bits of infrastructure that Microsoft's building out. But really, for the planetary computer to be impactful, it comes down to partner applications. It comes down to the things that our partners build on that technology that then turn satellite data and analytic infrastructure into insights and action, right? And that can span everything from single layers of insight, such as a new land cover product, through to operational infrastructure. And I'll give you some examples of both of those going forward. So let's start first with the most recent product we've released, which was together with Esri and Impact Observatory. We took all of the Sentinel-2 data for the world. And I say we, obviously I mean Impact Observatory. I didn't do anything particularly useful here personally. But what that team did was they were able to take 5 billion hand-labeled Sentinel-2 pixels, use that to train a model for a 10-class land cover land use map. And the real power of the distributed computing here is that once they trained that model, they were able to run it on the global data set for 2020 inside of a week. So they were able to distribute that computing and run it incredibly quickly. And where that gets us to is a point where that algorithm, that ability to produce a land cover product, is now moving into a domain where it can be run, in essence, almost in real time. So it's something that could be run at the end of every growing season, or it could be run at the end of every year and be available within weeks rather than within months or years. And that's a real step change, I think, in terms of land cover products. The other thing that I personally find quite exciting about this, so the annual land cover product for 2020 is available today through the Planetary Computer as an open source data set. However, the analytics themselves, the trained models, are also available on a fee-for-service basis through the Esri marketplace. And so that's another one of these models where we're seeing a blending between investments in public good data, but also this infrastructure enabling innovation and new business models, new technologies that can be used by farmers, by governments, by local communities who want to better understand how their land cover is changing. And that's just one example of this. We often speak in Australia about the potential for economic growth from Earth observation. One of the things that, in addition to our sustainability goal, is how do we enable companies and how do we do things like the Space Startups program that Nick talked about? How do we bring those together to enable new innovation in the space sector in Australia and globally? One of the points I really want to emphasize, though, is that it's one thing to produce a global product. It's one thing to produce global infrastructure, but if you're actually going to have impact, ultimately that technology has to be trusted. You have to be able to, if you're a company who wants to build a service, if you're a government who wants to build a platform, you need to actually trust and understand the technology. And that's one of the reasons that the open source and open architecture nature of the Planetary Computer is so important, is it actually enables people to control the pieces that they want to control, to take ownership of the pieces of their platform that they need to take ownership of, and to implement it in a way that retains sovereignty. And I want to play a video now from the Pacific talking about Digital Earth Pacific. So we've recently had a letter of intent between Microsoft and the SPC, where the Planetary Computer is now being used to enable and empower the SPC with a whole bunch of partners across the Pacific Island nations, countries and territories just to the east of Australia, to actually build Digital Earth Pacific. So let me show this video explaining what's important to the Pacific for this capability.
One of the key areas that we've been using Earth observation in terms of assisting our members with development has been in the natural disaster space, and particularly around providing the type of information that helps them plan for disasters, but especially respond to disasters. And when tropical cyclones come through, we're able to use the satellite information to map damage to infrastructure and also flooding in low-lying areas. One of the other key areas that's becoming ever more critical for the region is around coastal impacts and mapping coastal processes. Not only the coastal impacts from things like wave impacts and how that might erode the coastline or coastlines might change through storm events, but also mapping where mangrove and seagrass communities are, because these are big sources of blue carbon for the Pacific. So a really exciting development in that space is that we're moving from the projects that we've been doing in an ad hoc basis up until now to a more systematic program of understanding the needs of the Pacific Island communities in this space, and then particularly understanding how they go from using the type of information that we get from Earth observations to making decisions in terms of sustainable development, what those barriers are and how they can overcome those barriers. So what we're really hoping to achieve is an operational Earth observation system that's going to take generations of freely available data, bring it together in a sensible way and in a Pacific context that's going to allow people of the Pacific to make decisions based on good evidence in terms of how they can deal with climate change and disasters for the development of their countries and their communities. One of the key...
Nope. Always the risk with the YouTube video. One of the things that is enabling Digital Earth Pacific, one of the things that's really important about the Planetary Computer technology is actually that it gives the SPC, in this case, the ability to actually implement their own clone of the compute hub. So the way Digital Earth Pacific will actually work is that they will build, own, run, and operate and have complete control over who can use, who can access their own version of the Planetary Computer's compute hub. They'll have that as Digital Earth Pacific. It'll still be accessing all of the global data sets that are being managed and corralled by Microsoft. But Digital Earth Pacific will be a sovereign capability of the SPC and of their Pacific Island members. And what's really important about that is that sovereignty is a key issue to the SPC. It's a key issue to their member nations. So back in 2019, when Australia hosted the Geo Ministerial and Geo Week, there was a Talanoa moment where there was a workshop where many of the Pacific Island nations who were here for Geo came together and issued a statement really emphasizing how they wanted the global community to work with them as they built out Digital Earth Pacific. And it's one of the things that I'm personally really proud of, is that Microsoft's able to answer that call, where we're able to bring technology to the table that is able to be adapted by the Pacific for the Pacific into a sovereign operational Earth observation platform. And I'm going to be really excited to see how that progresses going forward as we start to put satellite data into the hands of some of the countries that are at the absolute forefront of the impacts of climate change into the future. So that's one dimension of trust. There's another dimension I want to talk about, which actually builds off some of the work that Nicholas talked about around with Space Gals. So I'm going to show another video of a program that was a partnership again with CSIRO, with NEST, and with Indigenous Rangers up in Northern Australia, and talk about some of the elements that sit behind that actually help translate Earth observation not only into data, but actually into trusted insights.
Ai no ngau di o kuno kena ngadu opir kon gari piro ambiri me almangi KJB mani muna change kon gani all give me.
I'm a proud Larrakia man, and I work here in Kakadu as a Cultural Heritage Officer. Our country and traditional owners have always been connected. We have gathered knowledge across the seasons to listen to the country. We need to find the best ways to care for the land, using our knowledge and new learnings. Magpie geese are an indicator of the health of our country. Watching the patterns of the geese, they tell us where extra care is needed. A dense weed called paragrass is overrunning wetlands and destroying where magpie geese live. We're using drones to monitor parts of the wetlands. They help us see the areas of the park which need our care. We're combining this information with our knowledge, Microsoft AI and science to change the way we work on the ground. It's showing us new ways to manage wetlands and help the magpie geese thrive. With this information in our hands, traditional owners can be front and centre in decisions made about country. Every day, we work to look after Kakadu. We're making sure it's here for future generations.
So I mean, the impact of that sort of work is extraordinary. And I know in this particular case, it was a drone approach, but it's all part of a bigger program that also includes the Space Cars work that Nick talked about. But that ability for targeted on-ground management informed by AI to actually go from, in 1 year, being able to observe only 50 magpie geese to 9 months later, 1,800 being counted is a staggering improvement in the health of country in this case. But one of the things that underpinned that work that actually allowed it to be effective was the ability to build trust in the actual tools and the technology. So quite clearly, some of the sites, and in fact, many of the sites that the drones were collecting data over were sacred. They had real cultural importance to the communities there. And so the actual AI techniques, the data management that was built at the heart of that, had to be able to deal with that. So in fact, they built these spheres of data control, if you like. So all of the data that was collected went first of all into a central repository, a central sphere that the traditional owners, the rangers, the elders had control over. They could actually choose then which of that data got released to their researchers and collaborators that they were working with. So that group then had a set of data that they could collaborate, share notes, understand, and grow their understanding of how to use the technology together. And then collectively, that group could choose what got shared out to the public. And really that point of how do we take technologies, how do we take data management techniques and not just think about the value of the environmental management, but actually what's the infrastructure, what's the technology, what are the advances in ethical use of data and ethical use of AI that actually also enable more trust, more use, more impact from those data sets. That's something else that's really critical and something that kind of fits under all of these projects in terms of methods of working and ways in which Earth observation data can actually be translated into impact if we can build that trust in it and if we can build ownership and a sense of sovereignty, which again really comes back to the importance of these open technologies, open standards, open architectures being at the very heart of the planetary computer infrastructure and being such a core part of helping translate Earth observation data into on-the-ground impact, which is really what all of us are trying to achieve here. So I want to wrap up to make sure we've got some time for Q&A. I want to try and just reflect back again why Microsoft is investing in this, why we are putting so much effort, energy, and resource into the planetary computer and into sustainability writ large. And to be honest, this quote from our Chief Environmental Officer really makes the same point. We need to do it quickly, but for us to be effective, we have to work in partnerships. It is what we all collectively do together where we are able to leverage technology, environmental science, new ways of thinking, new ways of innovating, and take it to scale. It's the ability to do that together and to do it quickly that will actually translate into impact on the ground. And frankly, we don't have time to waste to get started on doing that. So thank you all for the time today, and I'll leave you with a couple of the key links up there. And I think, Ashley, I just saw the flash up for questions in the chat if we've got them.
Thank you so much, Nick and Trevor. That was amazing. We've been capturing all the different links. And for those that have worried that they're missing anything, we will be sending out a summary with access to all these different sites and the videos and things that you've shared. So big thank you from us. We have a question from Mike. Thank you, obviously, to you both for presenting. Touching on cloud computing, I was curious to know what infrastructure Microsoft uses to minimize CO2 emissions from large, computationally expensive operations that space and other machine learning models use.
So I'm happy to have a first crack unless you want to, Nick.
No, I think this is a Trevor question, I hope.
Yeah. No, look, it's a great question, and it's one that is front of mind. So if I take aside from our sustainability work with the planetary computer and go back to our very first commitment, and that is that Microsoft will be carbon negative by 2030. Right? So that is a huge effort and focus for us. And there's a number of ways we're doing it, but in terms of the cloud computer, a big part of that is actually shifting to 100% zero carbon energy, basically, for those data centers. So we actually think that technology has got a fundamental role to play in cloud compute, and cloud compute at scale is a critical part of solving the climate crisis, of actually helping find energy sources that allow us to grow, that help drive growth, but do it in a way that isn't destroying the climate and isn't destroying the environment. So our commitment writ large is to be carbon negative, and I just emphasize the negative. We've been carbon neutral since 2012. What happened in 2020 was we recognized we had to accelerate that. We had to go much more ambitious and much faster, which is why we made the shift to carbon negative. Part of achieving that is moving our data centers to 100% renewable energy, 100% zero carbon energy 100% of the time. The other part of it as well, though, is driving down emissions across the company as a whole. And equally, we recognize that most of Microsoft's emissions are actually in our scope 3. So when we talk carbon negative, we're talking across all 3 scopes of our emissions. So how we're dealing with our scope 3 emissions is to drive those down as well. But equally, we recognize it's very, very difficult to drive down all of the emissions in our supply chains, in our value chain. So we're also investing in carbon removals. And I'm conscious I'm going on a bit of a rant, but I will just say one last thing, and we can provide a link for this. You know, last year Microsoft undertook what was, at the time, I'm pretty sure, one of the biggest carbon removal purchases ever in the world. And we did that in a really transparent fashion. So we went out to market, we requested you know, an open market for removal proposals, but once we purchased the removal that we've used, we then published a white paper that really went through all of the detail of our assessment of the market, of what those removals looked like, how many of them were, you know, comparatively short term in their durability, so less than 100 years or up to about 100 years durability. We've published all of that with our own assessment of the market. We're investing to try and mature the market for carbon removal, because that's going to be a key part of the globe. And lastly, we then published those key messages in our assessment actually came out in a paper in Nature about a month ago, I believe. So just that constant drive to be transparent on every aspect of sustainability, that is a really important part of Microsoft's work here.
Yeah, just sort of add a bit of a space angle to that. Just sort of following on from what Trevor was saying in his last point, sustainability is a Microsoft, you know, it's across the entire of Microsoft, right? And space, it is no different. So sustainability, sort of environmental consciousness is in everything that we do with space. So whether that is sort of working on space debris solutions or things to manage space debris, sort of through to that work that we saw with CSIRO and managing land better. Environmental sort of considerations and sustainability is considered at a Microsoft level.
Thank you, and it's great to see both of those perspectives. And as Mike said, thank you for such a detailed response. It was quite fascinating. I sort of wanted to take a step back. A lot of people are saying, how do we get into, you know, the space sector? Where are the opportunities? And particularly for those that are starting out on their journey, I'm conscious that we often get a lot of students or even, you know, we're all lifelong learners. So for those just kind of starting out on their space data career or looking at what those opportunities might be, keen to sort of hear, you know, how do you get into the sector? What are some of the fundamentals that are, you know, important to get across and that may lead to, you know, further growth in the sector?
Yeah. So I think people often have this idea that space is this very narrow industry segment, but the space touches, you know, almost every industry. I would say every sector in Australia uses space technology or space-enabled technology in some way. So I think finding those aspects of different industries that have space elements, sort of understanding them and how you can sort of pursue them further or investigate them further. So, you know, whether that is insurance and being able to sort of understand property or damages through satellite imagery, or agriculture and understanding landmass through satellite imagery, or through to sort of what we talked about with the International Space Station about genomics and understanding astronaut health. And there are a huge amount of different segments where space data applies. So to summarize, I would say sort of look more broader than just sort of that narrow space industry vertical.
Thanks for that, Nick. I wasn't sure, Trevor, whether you want to add anything onto that. But I think that, you know, if we look at the Australian Space Agency and their priorities, the Earth Observation Roadmap has just been released, and we'll make sure that we share that with everyone as well, which starts to sort of lay out, you know, where they see the growth in that sector. And obviously a lot of the work that we're talking around is around Earth observation. From our perspective, from the Space Data Analysis Facility, we're looking at, you know, the satellite imagery and that linkage into the space sector. But as you touched on, you know, with some of those examples, particularly where we're looking to protect the land, it's also looking at drone data, and you know, there's a whole series of different touch points that we need to gather and look at it so that we have a holistic approach. Keen to hear, Trevor, like, you know, certainly there's that sustainability and also the conservation of our Earth and you know, for those citizen scientists that are out there, is there ways that they could potentially get involved, or things that they can, you know, learn more about, so that we can, I see a lot of bright young minds that are really passionate about protecting the environment. So what are the ways that they could get involved?
Yeah, look, I mean, there are so many that's an interesting one to answer, right? So, and it does, I guess it does relate back to the last question as well. You know, a lot of the work that needs to happen in the Earth observation space is the ability to kind of work at that intersection between environmental science, machine learning and data science, big data analytics. And I actually think if you're able to bring any of those skills to bear on these sort of problems, and be able to think, well, how do I bring data science skills to bear on analysing Earth observation data, and driving towards kind of multidisciplinary teams is really one of the things that'll be really effective, I think, in getting into the sector, but also driving change. In terms of citizen science, I think, you know, there's a bunch of work happening, but it really depends on where their own skills are. So, you know, for example, things like the planetary computer, they're available. That is open to anybody who is inclined to go and get an account. Go and play, go and start exploring the data, see what inspires you, see what it tells you about your own community, about your own part of the world, or about parts of the world that you're interested in, and start to build up your skill set there. Look to grow. I would think the other part of this is networks, right? I mean, one of the things that was exciting about the chance to come and speak here today is to connect more broadly, to connect with the Earth observation and the data science networks in Australia, to connect with those through either universities, through local groups, and start to bring a passion about the environment, about space to bear on problems that you are passionate about.
Absolutely. No, thank you. And I think that even just being able to share some of those videos with others as well, and inspiring, you know, certainly the next generation, but also I think there's a lot more of a social conscience that we have, and that collective, you know, energy that we all need to start addressing it now. Excellent. I'm conscious of time, and I don't know if anyone else has got any sort of final questions, but would love to hear some of your, you know, some in closing, some words of wisdom, or you know, that encouragement. I think we certainly had a call to action to start, make sure that we're protecting the planet, and I love that perspective as well, Nick, in terms of we can all be a part of the space sector, and in fact, you know, sort of thinking about how we're already using those space technologies each and every day. I know a lot of the you know, apps that I use, particularly they're tracking different data sets and informing like whether I'm going to get wet or not, or we've got today it's more about actually trying to stay a little bit cooler. But you know, what, any sort of final words before we wrap up for this session? Thank you.
If it's words of wisdom, I'll let Nick kick us off, and then I'll try to think of something.
Oh, Trevor, I was going to reiterate some of your words of wisdom, which I really liked. I sort of liked Trevor's words about be curious, sort of find what interests you and chase that down. You know, pull on those threads, whether it is sort of space data, sustainability, just space in general, and figure out where your interest is and go and chase that down. And I think that is the best way to have an impact both in the space sector and sort of more broadly in life.
Hard to top that. I might try to take a different tack. I might try and reflect some of Nick's points. I would emphasise with one of mine, success in the kind of sustainability challenges the world is facing today will come through partnerships. No one person, company, organisation has got the answers, or all of the answers to all of the problems that we face. So combine that curiosity that Nick talked about with a sense of partnership, of collaboration. You know, that's one of the reasons companies like Microsoft are building infrastructure like the planetary computer, while we're investing in things like space startups, is looking for ways that we can pair our technology and our ability to innovate with, you know, new companies, new ideas, new expertise to drive change and to drive impact. And I think if you go into this sort of a sector with that perspective of actually it'll be collaboration and partnership that drives the difference, I think that is the only way we can, frankly, we can affect the change we need in the very short amount of time that we have available to us.
Thank you. And I love that you both sort of reflected on each other's words of wisdom. So look, a huge thank you on behalf of everyone that's watching us live and obviously watching a recording a little bit later. For those that want to learn a little bit more, the Australian Space Data Analysis Facility, we have launched our ASDAF Academy, which has a lot of introductory sort of tools and things like that to get you started. And we'll be certainly sharing all of Microsoft's tools and promoting the ways that people can get involved with the space data. So thank you so much. It's been great to have you both and have this discussion. And as you say, it's about sharing this new knowledge and making sure that people are aware of the opportunities that are out there.
Wonderful. Thank you very much
Thanks for having us.
Brilliant.
Thank you.
Thank you.